Welcome to i3TV. Thanks very much for joining us. I have with me today Luke Neville, the Managing Director of i3 Solutions London branch. Luke, welcome.
Thank you, Damien, and welcome to everyone who's tuning in to i3TV.
The topic of cooling a data center is one of those perennial subjects which continually produces new challenges, I think, particularly in the light of the hot summer we've just experienced. So our first webinar, it concerns the mechanical design of data centers. And I guess what brings this into view is a hot summer in the UK and actually throughout Europe, wherein we saw temperatures in London, in the urban heat island, going above 40 degrees, and a couple of very, very high profile data center shutdowns as a result. And the question is, as we feel more the effects of climate change, can we expect a greater number of data centers to shut down as a result?
So it's a very interesting question, Damien, and something that a number of people will be very interested in the answer to. It's not a straightforward answer, but there's a number of factors which all tied together do point in the same direction. So there's, as I see it, there's four elements that affect this. There's the extreme weather, which you've mentioned, which is without a doubt occurring. We're getting record temperatures quite regularly seen across the globe. And as you mentioned, in London and the UK this year, we saw a new record high of over 40 degrees. That will put pressure on any data center or any cooling system which has a design set point associated with it. But in addition to that, we've got factors associated with the data centers themselves, which are also pushing us towards this tipping point of failures. And those, as I see it, are the fact that we're having more and more data centers spring up, reconstructed. So just statistically, when you have a larger stock of data centers, then there's going to be a larger likelihood of failure, whether it be related to design or operational issues. Additional to that is the data center stock that is available at the moment is aging. And as it's aging and the equipment is aging, that pushes us up the other side of the bathtub failure curve. And you will expect to see more failures associated with those facilities as well. And the final part, which it's been known for a while that data centers are particularly underutilized typically. But more recent developments, more typical design and construction of data centers at the moment are heading towards a much higher utilization. So historically, you might have sort of colo operators that have their stock operating between 30 and 40% of utilization, which gives you a large buffer of comfort for unexpected weather or unexpected sort of design conditions. But as you push the utilization of the facility up to 70, 80%, you're removing much of that comfort zone, which means if data centers which were existing were utilized at those levels as opposed to much lower levels, it's likely that we would have had many, many more failures over this summer.
I guess where that sort of, it kind of prompts the question, how do people go about, or how do companies like i3 Solutions and end use go about designing the cooling architecture for their data centers? What factors do they take into consideration?
Okay, so the starting point for any data center design is either a client brief, which is very specific to the client requirements, or a discussion between the consultant and the client to define that brief. And when that brief is pulled together, there's a number of items within it which are associated with design, and it's not just data center design, it's design of anything. There's a balance of risk and reward and cost, which you have to find a compromise on. And so whilst you could quite easily design a data center to operate comfortably with air-cooled chillers at 50 degrees C, that would not be practical for a UK or Western Europe installation, because the cost associated with delivering that would mean that they would no longer be competitive with the market, and wouldn't be able to sell their space.
And I guess a part of those considerations are going to be, for example, where the data center is actually located. The kind of the local ambient conditions are going to affect the way that you call what's within the data center.
Yeah, that's definitely correct. We've focused a lot of discussions around the UK, but that is an environment which is reflective across most of Europe. Southern Europe is certainly a lot warmer. Northern Europe is certainly a lot cooler. But local ambient conditions are always a big factor. But irrespective of that, looking at the weather data that's available, there's always a set point that's agreed upon, which reflects the local conditions in any given environment. And it's the deviation or addition to that set point, which is the discussion at the start of the project, which is the agreement with the client, and therefore the boundary or the limit of the risk and flexibility for the operation and cost of the installation.
Got you. So I guess what you're hoping to achieve is what's a temperature that you can accept, which is nice and economic to run at, and how much risk you're prepared to accept if that set point is breached, if it runs over.
Yes, exactly. And so safety conscious clients might ask for a larger coverage across or above that set point or that agreed design point. Some clients who are not expecting such high utilization might wish to run closer to that and have a lower capital cost associated with the equipment and installation.
I guess that one of the challenges that we face is that, you know, if you're designing a data center in London and all of a sudden the temperature in London becomes more like the temperature in Seville, then you've got a bit of a challenge for a data center that's expected to run for, you know, a 20-year life cycle.
Yes, and that's the biggest concern about the environmental changes at the moment is there are predictions, but predictions are only so accurate. And I don't think a few years ago people would have predicted that the summer peak ambient in the UK would have so quickly elevated above 40 degrees. But there are certainly things that can be done with system and equipment selections which can bring some comfort. But it's always a balance about how much you want to allow for, and it's not just cost, but it can be spatially as well. So allowing for additional plant to be installed in the future to give you that capacity is a good option, but that's footprint which you're not utilizing to sell space, which then brings inefficiencies into the operation and therefore lowers your profit for a given footprint of site. There are some other things which we typically incorporate within designs, such as specifying chillers to the set point defined between ourselves and the clients, and then to operate beyond that set point, albeit at a lower capacity. And what that does is it softens that limit of the cutoff. So it's not a binary result, and such that if you get to 42, 43 degrees and your system selected 1 degree lower than that, it won't all shut down and have a cascade failure. What the result would be is it would still operate, but the capacity would be reduced. And so that allows you to increase the hall temperatures and keep the system running, or utilize the reduced operational capacity of a site to keep the system active and not have thermal runaway and have to recover from extreme temperatures within the halls.
Got you. So are these, is that potentially the challenge? I know that Ashtray, you know, a few years ago said, well, we could run data halls at a higher temperature in order to achieve greater cooling or greater efficiency in terms of power use, lower PUE. And we've just seen this announcement about Meta proposing to run their halls at 90 degrees Fahrenheit, 32 degrees centigrade. Are there challenges for them associated with taking that approach?
So we will always advocate operating spaces at higher temperatures, but it gets to a point where there's a number of considerations you need to bring into that discussion. data centers, whilst are typically unoccupied, they will have personnel within them. So there's only so far you can push them whilst you have people working at the back of those servers and experiencing the temperature that's being sort of discharged from them. So you've got to be careful of that. But the biggest potential concern that we see with operating facilities at a higher and higher temperature is how they react during a power failure and sort of a transient a blip in the cooling system. So there are ways to overcome it, such as you put all the cryo units or the fans on UPS, you put the pumps on UPS, you have large buffer vessels to ensure that you've got capacity to ride that through. But it brings, again, additional complexity into a data center system. And when there's more complexity, there's more chance of failure. So it's definitely a move in the right direction. And it's great to see that someone's actually starting to push the temperatures from the ASHRAE recommended to the ASHRAE allowable. And we know it's been happening for some time. Hopefully more people will start following along that vein, but we do need to make sure we pay careful attention to the transient analysis of the failure of the cooling system.
Do you think, I mean, I guess on my own experience and my experience of walking around data centers isn't that great, but it does seem to me that most data center managers like the white space to feel nice and cold, because then they know that the heating, that the cooling is actually working. It's going to be hard to wean them off that kind of approach to data center cooling. However, I think the other thing that strikes me always is the noise. Do you think that blowing air around is kind of going to be appropriate for cooling the sort of high density equipment that the server manufacturers, for example, are starting to build now?
Air will always have a place in data centers, even with additional cooling systems that we're looking at deploying across data center facilities at the moment. They're not 100% efficient. They don't pick up 100% of the heat. So you will always need some sort of ambient cooling system within a data center. There's been a great deal of progress made since the late 90s, early 2000s, where data centers were 21 degrees C plus or minus 1 degree C, and it was a de facto requirement of the equipment. So that is we're slowly moving away from that, and it's good to see that we can use that to bring the efficiencies into the operation of the system. And I forgot what your question was at that point, Damien.
That's okay. I guess where I was going with it, Luke, is do you think that air is going to continue to be appropriate, or are we going to see, as some of the predictions suggest, a move towards liquid cooling in the very near future?
Yeah, so with densities slowly increasing, I think we've always had predictions of 100 kilowatt, 200 kilowatt racks since the invention of the blade server, and although they do exist, it's not common to see that sort of deployment. But as the densities and just generally the size of facilities is increasing, it's becoming ever more evident that not only to allow us to cool that system effectively and efficiently, but to also give us the opportunity to actually recover some useful heat from data centers as opposed to just discharging it to atmosphere, that liquid cooling direct to the chip, picking up water at 60 degrees, in some cases even higher, is definitely the future of data center cooling.
Well, on that bombshell, I think we'll leave it there. Thanks very much, Luke. Join us for future broadcasts of i3TV. We are going to be covering in greater depth liquid cooling. We'll be looking at some of the challenges which air cooling is presenting, and some of the best practices that you can deploy in order to overcome some of those things. And also we want to look at water use. So those are topics we'll be looking at in coming weeks. We look forward to you joining us again. Thank you very much.